Hello, everybody. Hopefully you had a good break. I would like you to watch this quick little video. It's been a while. I bet you're happy that you took your final before break, but we are in the middle of a chapter right now. We already did 5.1 to 5.3 already before break, and you guys took a quiz on it. We have 5.4 to 5.6 to finish now after break. So basically what I'm gonna do today in this quick little video is to review everything that we did in 5.1 to 5.3 so that you're ready to go when you come here tomorrow. So basically in 5.1, the only thing that we learned in 5.1 basically is this. This is f of x. And basically in 5.1, we learned how to find the max and the minimums looking at a chart. So basically, you have a max here, but these keep going up. So this is called a local max because you have no absolute max in this picture. So let's just put it right at 0.3 is a local max. You have two absolute mins right here. You have two absolute mins because that's the lowest they can go. Absolute min, again, I kind of drew this 1, 2. It looks like about a negative 2.5, and this looks like a positive 2.5, comma, let's make this about a negative 3. So that's all you learned in 5.1. You learned how to stare at graphs and figure out maximums and minimums and local max and absolute max and mins. Okay, moving on to 5.2. For example, y equals a negative 2x to the third plus 6x to the second minus 3. We learned how to find the first derivative and set that first derivative equal to 0. I'm going to take out a negative 6x. So x could either equal 0 or x could equal 2. By setting the first derivative equal to 0, and you can make a sign chart, a negative infinity to 0, 0 to 2, 2 to infinity. This is the derivative, and this is what the original would be doing if you guys remember this from 5.2. I'm just going to hurry this up, but I'm going to try a point, and you have to put it back into the derivative. And it's going to go negative, positive, negative, which means the original graph is decreasing, increasing, and decreasing. And then we can even go farther and find the double derivative of this, which is a negative 12x plus 12. All I did was take the derivative of this, set that equal to 0, take out a negative 12. And you're going to get x equals 1 for the double derivative. Again, you make another sign chart. A negative infinity to 1 and 1 to infinity. This is the interval. This is the double derivative. And this is the original. I'm kind of going fast, but I think you remember how to make sign charts 1 and sign chart 2. This is going to be a positive and this is going to be a negative. Double derivative teaches concave up and concave down. So, where is the graph increasing? It's increasing from the interval from 0 to 2. Where is it decreasing? It's decreasing from a negative infinity to 0 and 2 to infinity. C, you went from a negative to a positive. You have a min at 0, comma something, and I got to fill it in a minute. And since I went from positive to negative, I know I have a max at 2 comma something, and I got to figure out what that is. And how do you figure out these? You plug 0 back into the original, you plug 2 back into the original. This is gonna be a -3 when you plug 0 back in, and this is gonna be 5 when you plug that back into the original. D, concave up from a -infinity to 1. E, concave down from 1 to infinity. And when you go from a positive to a negative or a negative to a positive, you have a point of inflection at 1, 1. Those are called sign charts. Okay, just a couple more things to go over. If you're staring at a derivative graph and you're not staring at an original graph, I'm just gonna make this easy here. That's 2, and this is a -2, and that's 0, 3. This is the derivative graph. And they ask you what is f of x doing? If this is the derivative graph, remember, you can do this. All of these on a derivative graph means that these are all positive slopes. And this is below the x-axis, so that's a negative slope, and this is below the x-axis, so that's a negative slope. So what's the original graph doing? It's decreasing from a -infinity to a -2, union with 2 to infinity, because that's the green. It's increasing from a -2 to 2. Again, I went from a negative to a positive, so if I go from a negative to a positive, there has to be a min at x equals a -2, and since I went from a positive to a negative, there has to be a max at x equals a +2. This is the derivative graph, so I can't specifically tell you what the y value is. I can just tell you where there's a min and a max. Okay, just a couple more things. I have 2 more things to talk about, and that's it for 5.1 to 5.3. The mean value theorem says that if you do y minus y over x minus x, which is called the slope, this should also equal the derivative. So if you have y equals x squared plus 2x minus 1, and you're trying to do the interval from 0 to 1, I'm going to plug 0 in and get a -1, and I'm going to plug 1 into there, and I'm going to get 2. So these are my points. This is my interval, and all I did was plug it into there to get my points. So if I do y minus y over x minus x, I'm going to get a slope of a +3. I'm just kind of going a little fast, but all I did was find the slope, plugging those in. The derivative of this is 2x plus 2. Solve for x, I get x equals 1/2, and it's called the MVT. And the last thing, and we are done. If you're given the derivative, how do you go backwards to the original? So, instead of subtract, this is a 1, you're going to add 1 to 1, so it's a 2, and you also divide by that power. 4 changes to 4x, and don't forget your plus c at the end, and this simplifies to a 3. So that's how you go backwards from a derivative to the original. Okay, I just wanted you to watch this video today and work on your packet also, the multiple choice packet from chapter 4. That's all I asked for you guys to do today, and see you guys tomorrow.